Okay, let's begin. Hello, everyone. I'm Arthur. I'm a customer engineer at Soda. And today, this webinar is going to show you how Soda, as well as Databricks, how you can basically use Soda to master data quality, especially in your Databricks architecture and infrastructure. So that's a picture of me. And just some housekeeping before we start. Feel free to drop any questions that you have in the Q&A section. We'll handle these questions either at the end of this call or maybe further offline as well. And also worth noting is that this video is being recorded and it will also be available for you to watch on demand after this call. So let's begin. This is the agenda for today. Basically, the key features and use cases of Soda and how it allows you to master data quality in Databricks using machine learning powered metrics monitors, using collaborative data contracts, and also once you have detected issues with metrics monitors and with data contracts, how Soda also helps you to fix and prevent the same issues from happening over and over again. But before we dive into how Soda helps you master data quality, I think it's also worth thinking about and reflecting on why we should master data quality in the first place. So what are some pressing issues or use cases for mastering data quality? So these examples that you see on the slide right now, they are not exhaustive, but they are very common stories that we hear in the modern data architecture, in the modern data landscape, and that's what drives many of our current customers to approach Soda for a data quality platform and tool. So here, for example, you see a message where you have, for example, executives, C-suite level leaders who are angry, for example, at the data team because there are certain strange looking amounts in reports and dashboards. And this would also lead, for example, to very costly wrong decisions. And of course, because these are important decisions that have to be made, these are important BI tools. So of course, they always demand for a fix as urgently and as soon as possible. So below you also see some graphs. How can no one be drinking cappuccino, for example? There's definitely something wrong with that visualization. You also have sales amounts that are negative, which as we know, do not really make sense. And finally, you see some solutions in terms of data quality, but these are very manual. For example, the manual execution of SQL queries to check for sales amounts, let's say, and having these tied into, for example, important KPIs or performance metrics. So in summary, why should you master data quality? There's a lot of inefficiency if you don't. There's also costly mistakes or decisions that are made with poor data quality. And of course, at the end of the day, with data, trust is very important. And if you do not master data quality, you have a lot of untrustworthy data assets that do not have any value for your organization and for yourself. So instead of all those strange looking reports, wrong visualizations, angry data consumers or executives or managers, why not basically master data quality and have it in order where you basically detect beforehand, before anyone complains to you, you get messages and notifications from Soda on your popular communication tool, whether it's email, Microsoft Teams, Slack, etc. And this is basically the ideal state where you have master data quality, where you have full observability and testing of your data, so that instead of getting poor feedback, getting angry consumers, getting wrong and costly decisions, you basically receive such notifications and have full control and mastery of your data and your data quality. So this leads us to the next and the main topic of this webinar today. How do you master data quality? So you can see it in two main sections, this webinar. How to master data quality. First, you have to detect. You have to set up rules. You have to use, for example, machine learning to be able to help you detect data quality issues. They will also send notifications that you see on this slide. But of course, that's not the end of the story. Once you know that you have data quality issues, you cannot just leave them lying there and happening on a regular and repeated basis. But there should also be a way for you or users in your organization to fix and also prevent these issues from happening over and over again. So if we put that scenario of mastered data quality into a slide, this would be it. And this is basically the 6 main use cases of SODA for data quality in your organization. So on the left, on the vertical, you see CDO and CTO. So CDO, we are talking about the business domain of your organization, whereas the CTO, that's more the technical domain of your organization, for example, where data engineers, platform engineers, etc. reside. With Soda, we are built as an end-to-end data quality platform and tool. So first and foremost, we want to bridge that gap between the business and the technical domains in your organization so that all types of users, whether they are doing more programming or whether they are like data stewards who have that business knowledge and the expectations of how data should look like, everyone in your organization should be able to take responsibility and contribute to good data quality. So that's the vertical perspective. But on the horizontal perspective, you see consumers, central team, and producers. As mentioned earlier, how to master data quality. First, you need to be able to detect data quality issues. And there, SODA allows users, especially business users, to very easily set up and validate business data quality rules. We'll have a look at the idea of data contracts later on. And also, we provide proprietary machine learning algorithms that users can easily plug and play so that you can leverage the power of machine learning and artificial intelligence to help you detect what we call unknown unknowns. So data quality issues, anomalies that no one in your organization has seen before, has experienced, or has expected. So that's where AI comes in very handy. So that was just about the detection of issues. For example, then you receive notifications of problems in your pipelines or with your data. But of course, it does not stop there. And that's where SODA allows you to take a preventative, a shift left approach to data quality. So for example, on the top left-hand corner, one of the use cases is fixing records at source. So how does SODA allow you to do that? In this webinar, we'll see in the SODA Cloud user interface how users can review not just the latest result of your check, but also the historical performance of that check, and also even see or access a sample of the rows that caused that check to fail so that they can dive even deeper and investigate and eventually implement a permanent and preventative fix for your data quality issues. In the middle at the bottom, we also talk about how SODA has a Python-based SODA library, which allows you to embed your data quality checks as early and as frequently as possible in your data pipelines so that you can fix and also prevent data quality issues, for example, from spreading across your data pipelines. So we have talked about detection and also prevention. So I think now it's worth jumping into the product SODA itself and seeing these use cases come to life. So if we quickly jump into the product, here we can see, let's see, retail orders. So in this data set called retail orders, as mentioned, one of the main use cases of SODA is to use our proprietary machine learning algorithms to help you detect data quality issues and anomalies in your data. So this is done using what we call metrics monitors. So you can see that this interface, there's no programming or coding required. It's just clicking of buttons. They can configure which monitors and which metrics they actually want to observe. And here you can see on the dataset level, for example, that there are metrics like the total number of rows, the change in your total number of rows, schema changes, as well as the freshness of data. So worth mentioning here is that these machine learning algorithms, they are proprietary. They have been designed specially by our in-house data science team that has also made contributions to international machine learning and AI journals. So these proprietary machine learning algorithms, because they have been developed and trained specifically for this process of data quality, so they have shown actually a 70% improvement in the detection of anomalies as compared to more publicly available models. Besides this improvement in the detection of anomalies, these models also have the benefit of giving you very quick time to value, because these models can be trained and help detect anomalies on up to 1 year's worth of historical data. So once you plug and play, you can basically define the window of time in the past from which you want to basically introduce these metrics monitors and use that historical data. And this is already a huge benefit as compared to, once again, more publicly available models, where more often than not, once you activate those models, you would have to let them run for, let's say, 3 to 4 days before they can actually help you generate any value and help you start detecting any anomalies. So besides the benefits of the model itself, if we jump into the user interface, here you can see, for example, on the schema level, that these metrics monitors, for example, can help you look out for any strange behavior in your schema. For example, the changing of the value type of your column, for example, the addition or the deletion of certain columns, and also the subsequent changes in the position of columns in your data set. So besides this schema metric monitor, we also, of course, have metric monitors, for example, for the freshness of your data, the total row count, etc. So here you can see once again that it's catered to all users. So there's no programming, so that even business users can use this interface very intuitively. So here, as we know, algorithms, they improve with more training and more feedback. So besides just giving you the points and the graph, for example, if an anomaly has been detected, users can actually select that point and they can provide feedback, for example, and tell the algorithm, let's say that this might be a false positive, so this should actually be expected, so that the algorithm can take in this user feedback and use it to detect anomalies more efficiently and more accurately moving forward. So we'll dive deeper into incident creation and management later on. But here, as mentioned, with that not just detection, but also preventative approach to data quality within the Soda Cloud user interface, when things fail, when issues have been detected, when anomalies have been detected, we also make it very easy for users to create incidents so that these can be assigned to the correct people. They can be redirected to the data sources so that someone somewhere is actually taking and implementing action to prevent these anomalies and or issues from happening over and over again. So what we've looked at so far are data set level metrics, for example, schema, as well as freshness of data. But worth mentioning also is that these metric monitors can also be created and configured on the column level. So here users can simply select columns on which they're interested to monitor certain metrics. And here, for example, you can see some example metrics that people can start monitoring on a column level. For example, what is the most recent timestamp, the freshness of the data, average and missing values. So later on in this webinar, towards the end, I'll also share some links basically to a huge release that Soda is about to announce in line with the Databricks conference. And there we'll also share more information about the additional monitors and features that Soda will be releasing for this as well as for the entire platform itself. So what we have seen so far are metrics monitors using machine learning to help you detect anomalies. But as mentioned, we also want to make it very easy for human users to basically define and generate data quality rules. So we see human-generated data quality checks and those machine learning powered algorithms as working hand in hand to help you achieve full observability and testing in your organization. So these features, they're not meant to work in isolation because at the end of the day, machine learning is great, but it's not perfect. And also human users, there are certain unknowns that they may not be aware of. So that's why Soda offers these two features as a complement to each other to help you achieve full data observability and testing across your data and organization. So here in this interface, you see that besides the metrics monitors that we saw earlier on, for a particular data set, you can see, for example, a list of all the checks categorized depending on whether they're on the data set level or on the column level. So how exactly can users basically build onto existing checks, for example? Here you can see that users can contribute to what we call a data contract. You can basically see it, for example, as a YAML file, which we see here. And here with this button, you can basically see how we bridge that gap between less technical users and more technical users. So less technical users, they can basically click on some of these buttons. They can fill in a form, and immediately these checks will also be introduced in the more programmatic way to make it easy for engineers to take these checks in this programmatic definition as a YAML file and embed them as part of your data pipelines, for example. So here you can see other configurations, for example, defining a fixed schedule with which to execute these data quality checks. They can also define variables that can be used, for example, as a data set level filter, so that let's say you only execute this contract on a partition of data in your data set instead of running your checks on the entire data set. So as mentioned, there are data set level checks, but there are also column level checks. So if you have a particular column, for example, that you want to introduce a check on, you can simply click on the button and then immediately you get an out-of-the-box selection of a check that users can easily click on buttons, fill in certain values in a form, and immediately introduce a new data quality check without having to do any coding or programming. So if we quickly jump back to the slides at this point, so what we have seen so far are the detection of data quality issues using a human-generated data quality rules as part of a data contract, and also leveraging SODA's machine learning algorithms to help detect anomalies, especially unknown unknowns that human users are not yet able to account or write rules for. So as mentioned, that would lead you to this stage where once you have those metrics monitors, once you have those data contracts in place, when a check or when certain checks have failed, when they are scheduled and executing on a regular basis, you then receive notifications like these via email, Microsoft Teams, or Slack, instead of getting complaints from the actual consumers of the data, for example. But of course, once you have received these notifications, your data quality journey should not actually stop there. There should be a process basically to fix and also prevent these same issues from happening over and over again. So if we jump back into the Solar Cloud user interface, so here you can see, for example, some checks. And if we jump into a check that has actually failed, here you can see first and foremost that users can quickly have a look to confirm what this check is trying to achieve. So once again, this is in the programmatic Soda checks language, but you can see that it still remains very human readable. So here it's looking for missing values in the last name column, for example. So here you can see that, as mentioned, you have not just the latest result of when this check was executed, but you can also have a historical overview of the status and performance of this check. So that, for example, if this check has been failing in the past 2 or 3 days, so not just in the most recent and immediate execution, this already gives users an idea of perhaps maybe some change that was implemented 2 or 3 days ago has actually started to cause this check to fail. So besides this historical context, we also provide what we call a sample of failed rows to give users even more ideas where they can start investigating why this data quality issue actually occurred. So here, for example, indeed, there are no or missing values in the last name column. And here with the other columns, with this sample of failed rows, users can start investigating and thinking, for example, could it be related, let's say, to the country code column? Could it be related, let's say, to the payment method, etc.? So worth mentioning here, and also in the context of Databricks, here you can see that because these values might contain sensitive or private information, and you cannot simply send it to Soda and show it in the user interface like this. That's why Soda provides an alternative where you can basically and very easily disable Soda from being able to collect that sample of failed rows and display in the UI. And you can instead replace those rows with alternatives. For example, giving users an SQL query, which you can then execute in your own warehouse, for example, in Databricks, in the security of your own architecture, where users can see those failed rows without having to send and expose them to Soda Cloud. Another alternative, of course, is that you can reroute those failed rows to a storage location within, once again, your own secure architecture and storage. So in this case, for example, we have rerouted those failed rows to a data set within Databricks. So this could also be, for example, a CSV file or a location in your Databricks file storage system. So on the topic of incidents, which we briefly touched on earlier as well, here you can see that users can also click and create incidents. And if we have a look at an existing incident, Within Soda, there are incidents that can be created. You can manage them within Soda as well. You can assign them, as discussed earlier on, to data owners and to data sources so that someone actually takes ownership of that issue and implements a fix for it. And worth mentioning here is that besides Soda's built-in incident management tool, via webhooks, you can also integrate this with external ticketing and communication tools. For example, Jira, ServiceNow, Azure DevOps, and also send notifications to popular communication tools like Microsoft Teams and Slack. So besides being able to fix records at source using incident management, using failed rows, another way that we allow you to shift left and take a preventative approach to data quality is using what we call the Python-based Soda library, where you can simply pip install the relevant Soda library depending on your data source, and you can start executing checks, executing those data contracts that business users also contribute to as part of your Python-based data pipeline. So here, we see an example of a Databricks notebook where we pip install the Soda library. Subsequently, we execute checks on that data. And then by setting up a connection with Soda Cloud, the results of all your checks and more information about these checks, as well as the data sets that these checks are being executed on, all this are sent back and centralized in the Soda Cloud user interface, as we saw earlier on, to ensure that you have a single pane of glass in a single UI for your users to review and take action on everything that is related to data quality. So we've seen the main use cases of Soda. So in the next slide, you can basically see that Soda is focused on data quality, but we make it very easy to integrate and tie Soda in with other tools in your modern data and tech stack. So without jumping into too much detail, we have seen, for example, how Soda can integrate with popular communication and ticketing tools via webhooks. We also saw, for example, in terms of data sources, Soda can execute checks on SQL endpoints and SQL-based warehouses, but Soda can also be used to execute checks on any data that can fit in a Spark, Pandas, or Dask data frame. So on the right of this diagram, Soda also provides a Soda Cloud API from which all your data quality information can be extracted and used to enrich, for example, popular metadata and catalog tools like Atlan, Alation, Colibra, and also the Unity catalog in Databricks. And it can also be used to create very advanced data quality visualizations and reporting. So with that, we can also have a look at an example of a visualization that was built on the Soda Cloud API. So this is, of course, in Databricks because that's also a key tool for the topic of this webinar. So here we see a Databricks dashboard, which uses data quality information from Soda via the Soda Cloud API, where you can see that not just high-level information like the number of data sets and checks and the health status, but you can also, with attributes on your check as well as data set level, you can create very advanced visualizations and reports. For example, the status of your data quality checks, depending on which data quality dimension they belong to. And also using numerical attributes for checks, where you can give checks different levels of importance. You can basically create what we call a weighted data quality health score as compared to something more superficial, where all checks are seen with the same level of importance and priority for your team or for your organization. So we have talked about the main use cases of Soda, how it helps you detect and prevent data quality issues, and also bridge that gap between technical and more business and non-technical users. And then we've seen how Soda can basically be integrated with many of your popular tools that you are currently or planning to use in your modern data and tech stack. So just to wrap up this webinar, to basically deep dive into some of these features that we have shown in this webinar, you can basically have a look at some of the past webinars that my colleagues and fellow customer engineers have also done. For example, using those machine learning powered metrics monitors, there are YouTube links, and also for data contracts, my colleague Hazem has basically jumped and spent more time looking at the exact capabilities and features as part of those data contracts. And then, of course, if you want even more Soda, there's a link right here. And this is basically early access to our Databricks launch in line with the Databricks conference coming up next week. And of course, signing up and you scanning that QR code and registering for early access also gives you a chance to win that very cool mechanical keyboard. So besides getting early access to the Databricks launch, these are also some steps that you can take to further know about Soda and to integrate and start thinking about using Soda to master data quality. You can, for example, join our Slack community. You can schedule a demo with us, or you can, of course, start diving into our public documentation to see how Soda can help you master data quality. So I've reached the end of the webinar, and let me quickly check for some questions. And yes, to sign up for early access, in the chat, you can also see some links provided where you can basically review the past webinars, which dive deeper into the features I've talked about, and also sign up for early access for our Databricks launch. So I see that, yes, I see that I've won, maybe just using this question to wrap up this webinar. So if I already have some data quality checks, how can I already, for example, integrate them with Soda? For example, if I'm using SQL. So worth mentioning here is that besides those checks that are defined in the Soda checks language, Soda also supports more custom data quality rules using languages such as SQL. So if we quickly jump into this data contract, I believe I have an example. Yes, here. So here, for example, in the data contract, you can also introduce or even reuse existing SQL queries that you might have been running on a manual basis. And by introducing them and using them as a data quality metric in your Soda data contract, these data quality checks can also be executed on an automatic and regular basis. So I think, so there's one question. Okay, there are a few more questions coming in. Does Soda have data profiling? Yes. So I can redirect you to our documentation where there are steps that you can take basically to profile data in Soda. So here there's basically step-by-step information. So profiling data with Soda, this will basically give you more information and the exact way to configure data profiling in Soda. So that's answered. It's at source. The data. So the quality checks were running on a catalog, but you're saying that you alert the business owner of the data. How are you determining whether your quality issues are originating on the from? Okay, so I think to answer the question of where or how to know exactly where your data quality checks or where your data quality issues are originating. So for example, as part of your contracts or as part of your pipeline testing, it will be very clear, for example, at exactly which data source. So here, for example, you can see which catalog and which database, for example, which schema, these data quality checks are actually being surfaced. And as part of your pipelines, because you're working on different stages of your medallion architecture, for example, so these indications as part of your checks and as part of your pipeline tests, this will make it clear at exactly which stage and at which part of your data architecture these issues are being surfaced, basically. Okay, so I think that should answer the question of where data quality issues are being surfaced. And I think this probably is a good time also to wrap up. So once again, feel free to sign up for our early access where you will get more information about the features and even more releases in line with the Databricks conference. And of course, feel free at any time to join us on our Slack community, schedule a demo, or deep dive into our documentation. So with that, that's the end of the webinar. Thank you everyone for taking the time and looking forward to join you on your data quality journey in the future. Thank you.